Alright, hi again. There's no disclaimer this time, so we're just gonna start the video. And on a side note, we're actually gonna start with the mark scheme this episode, so get ready. Alright, so looking at 3AI, we see that upon gentle heating, you don't actually need to write that. It melts, it dissolves, it changes to a liquid, anything. As long as you write that down, you're fine. And then after that, you have to write about condensation forming or just bubbling, fizzling. I'm not sure about vigorous boiling, but I'm not too sure about that. That's what we put, vigorous boiling at first, but, I'm not too sure about that. And then, of course, you have white residue or solid forming. You can also say like a precipitate, I guess. Again, I'm not too sure about that either. And then you guys should have obviously found the brown gas that was emitted. They said liberated. I'm pretty sure that's just fancy talk for emitted in British, but I don't know. And then if you guys tested for the gas, which you should have done, considering you guys saw that brown fumes were, made, you would have found that wood splint test, when you put an ignited one in, it'll just go out and it won't really do anything. If it's nearly out, it's supposed to reignite. My group didn't actually find that, but if you solve later on, you'll find that that should have been what we expected. And I'll go into that in a bit. And then if you tested for the litmus papers, pink paper should have turned brown, maybe brownish white, but that's not really bleaching. And again, I'll go over that in a bit too. And then, but if you did blue paper though, blue paper would have turned pink. So that's something interesting to go through as well. So yeah, and then obviously, like I said before, an unlighted splint that had embers on it should have ignited. We didn't actually get that in, but that's apparently what's found. And then you'll find that the gas was oxygen gas. And moving on to the next page for 3AII, for the observations of the first two tests, so aqueous sulfuric acid, that's H2SO4, you guys should have found no change for that. And then obviously for the aqueous ammonia, that's NH3, you guys should have gotten a white precipitate. We wrote cloudy white because it was kind of hazy, but I guess white works. A white precipitate, and then you guys should have found it to see what happens when you put extra of each, like either extra sulfuric acid or extra aqueous ammonia in, and then see what happens in excess. Nothing happened for the sulfuric acid, so you guys can just leave that. But if you put in extra aqueous ammonia in, you'll find that the precipitate is still there, so it is insoluble in excess, which is why they have that and bolded on the mark scheme there. And then we have for the subsequent observations, this, by the way, is for the NaOH. We need to find that it's cloudy white precipitate, and again, you also need to test for insolubility, which you just put in basically extra NaOH in, which is sodium hydroxide, obviously, and then you need to look for it. You have found that the precipitate is still there, just like how we did it for aqueous ammonia, so we know that it's a white precipitate. Again, we wrote cloudy white, but it's a white precipitate and it's insoluble in excess. Now, if you were to heat this up, you would have found that nothing really happens when you start heating it, and then if you put the aluminum foil in, it starts to dissolve the aluminum foil, which also kind of means that there's going to be a gas. If you had tested for litmus paper at this point, it would be a great idea. It would have been a great idea, at least, now that the lab's kind of over. But if you tested for all the litmus papers, blue didn't do anything, but red turned blue. So that's something nice. And yeah, that was basically all there was to that. So that means that you know that there's going to be NO3 and magnesium 2 plus ions, because if you look at the back chart here, you'll find that these characteristics that we just found match those two the most. All right, and then Mg has a +2 charge and NO3 has a -1 charge, so you're going to need two NO3 anions in order to match the charge of that Mg cation. So yeah, that's why we get MgNO3 for 3II, which is what they had there. And then ionic equation, I'm going to flip back to my paper later, and then you guys will see how you get it. But it's Mg2 plus aqueous plus 2 OH minus goes to MgOH2 solid. And yeah, that was all there was for question 3. Now let's go on to question 4. Alright, so now on to question 4, or more accurately BI. I don't know why I called it 4 earlier. But anyways, let's start with NaOH. So they say that if you combine your Fa7 with NaOH, you're going to get a white precipitate, and it is soluble in excess, which means that if you have more NaOH than you had initially put in, which was supposed to be around 1 centimeters cubed, you would have gotten that the precipitate that forms will dissolve. Now, for me and Jake, we actually didn't get that. We found no change. I don't know if we did something wrong, but for some weird reason, when we put in FA7 with NaOH, nothing happened. So we wrote no change. You guys will see that when I go for my work after this. And then for FA7 combined with aqueous ammonia, though, we got the proper reaction. So you're going to find a cloudy white precipitate. And if you had put in extra aqueous ammonia in there, which basically meant that you filled the tube basically almost to the brim, you would have found that all of that cloudy white precipitate dissolves into the solution. So you would have said that it's soluble in excess. And that's where that excess comes in, basically extra of that chemical. And then, of course, for the last one, which was acidified potassium manganate 7 combined with our Fa7, we would have found that you get a yellowish or orange kind of solution, and then you would get that after starch, you would get a black precipitate. So that's kind of what they say here: brown, orange, red, brown, yellow, yellow, brown. Basically anything that kind of looks like bromine, if you guys have seen that. Here's a picture of it right here. And then, obviously, it turns dark blue, black, blue, black. That's kind of like the same thing we did for our previous testing when we did that iodine stuff. So yeah. And if you guys didn't know that, you kind of should have known that starch is an indicator exclusively for iodine. So obviously that kind of helps with BII here. So we have our iodine, and then we need to figure out what matches with our cloudy white precipitate, and that is going to be zinc, which is found right here. See, the table kind of says that, and yeah. And then we need to test to see to confirm the identity of that anion. So what you can do is you can kind of go through either barium or use silver. We use silver, and that was kind of a intuition from Jake here. And then we found that if you put an aqueous silver nitrate in, you get yellow precipitate, and that's really all you need to put there. And then that kind of confirms that you have zinc iodide there. And yeah, that was all for the mark scheme. Now let's go on to my work. So my work is a little messy, as you guys can see here. But yeah, after I kind of wrote down, you guys can see the crossed out things, I said it doesn't reignite either. And then the other one is, so chlorine gas is released, paper was bleached. So the reason why I knew this was wrong was because we found at the end that MgNO3 is our Fa6, and in there is no chlorine gas. So obviously chlorine gas was the wrong test. And if you look at it, it combined with NaOH, and that would yield nothing but O2 gas. So obviously O2 gas is the only one that really works, and that just means we just did a bad test. But through intuition, I have to rewrite this basically saying it is not bleached, but the wood splint reignites, so oxygen gas is released. So we didn't actually get this through testing, but logically speaking, if you had done everything properly, this is probably what you would have gotten. And then to the next page, we basically just did everything that the mark scheme had there. So the table is basically the exact same. Again, we just did cloudy white instead of white because it was a little hazy. So then if you go down to Fa6, I just did the table searching thing, so Mg2 plus and NO3 minus. And then you'll find that the equation of everything is, they say you combine it with sodium hydroxide. So I just kind of listed at first MgNO3 plus NaOH, and then that would equal like MgOH2 and then NaNO3. So yeah, and then balancing that, you get a 2 in front of the NaOH and then a 2 in front of the NaNO3. And then if you split these up into ions, you get Mg2 plus 2 NO3 minus plus 2 Na plus 2 OH minus. And then MgOH2 is a solid, so we leave that alone. And then we have 2 Na plus and 2 NO3 minus. The 2 Na plus and 2 NO3 minus cancel out on both sides, so you're left with Mg2 plus aqueous plus 2 OH minus aqueous, which gives us MgOH2 solid as our final ionic equation. And that's how we did that. And then obviously for Bi, you guys can see me and Jake didn't get any reaction. I don't know what we did wrong, but we're just gonna keep this, I guess. So yeah, we didn't actually confirm that it changes color. So I don't even know if this mark scheme is wrong or if we just did it wrong. So I'm just gonna leave that up to you guys. Tell me in the comments, I guess, what you guys got. And then yeah, after that, everything else was basically the mark scheme. And that was the video. Hope you guys enjoyed that. And again, if you guys have any questions, you guys can drop that down in the comments. And if you guys got anything different for that no change that me and Jake got for BI and then combining that with Fa7 and NaOH. Please tell us in the comments because I have no idea what we did wrong. So yeah, hope you guys enjoyed. See you guys next time. Bye!